The second triangle congruency shortcut we're going to be looking at is called side angle side, SAS. Notice that A is located in between the two sides, and what we call that is an included angle. So we have to make sure that the angle is sandwiched right in between our two sides. And so if we take a look at these first two questions, we want to find out, is the angle an included angle? And so I can see that here are my two sides, side AB and side BC. The angle they give me is over here. It is not included. So no, the angle marked is not an included angle. It's not smack dab between the two sides. In fact, the angle that is the included angle is angle B. That's the angle that's sandwiched in between the two sides. On our triangle on the right, here are my two sides, so that's the SS part of side angle side. What I want to check for is the angle smack dab in between those two sides? And yes, in this case it is. So angle U is the included angle for side angle side. So just take a look at those two diagrams, make sure you understand the difference between them, and let's go ahead and do a little bit more work with side angle side. So the question this time is, can we conclude that the two triangles are congruent to each other? Well, we have two options at this point to use as shortcuts. We have side, 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 which we looked at in the previous set of videos. We also now have side, angle, side. In this case, I can see that I have two sides identified. Two sides are matched up. So there's the SS part of side, angle, side. As we just talked about, we also need to make sure we have the angle included in between those two sides. And I can see that, yes, this situation we do have that. So yes, I can conclude that the triangles are congruent because of side, angle, side. And you may want to write out why you know that. I know that AK is congruent to KT, and I know that DK is congruent to SK, and then I know that angle KD is congruent to angle TKS, those included angles. So you may want to be more specific and write that out. Otherwise, we're going to say yes, it is because of side, angle, side. And again, I'll write my congruency statement. The order of the first triangles don't matter. I prefer they're in alphabetical order. The second triangle may or may not be in alphabetical order. Make sure things match up. This matched up in the correct order would be triangle TSK. Same question. This time we want to know if these two triangles are congruent to each other. This time the only thing that we're given is that ABCD is a rectangle. And so I can see that I have two right angles in there. I've gone ahead and identified those already. But that's all I have to start with. So let's see if we can add any tick marks to this diagram. Since this is a rectangle, I know that AD is congruent to BC because opposite sides of a rectangle are congruent. I also know that the top and bottom will be congruent. So AB and DC are going to be congruent. If I take a look at my diagram now, once again I have two sides marked and I have the angle in between them, and it's a right angle, but that's okay, they're congruent. And so yes, I can conclude that these two triangles are congruent because of side, angle, side. I have two sides and the angle in between them. For my congruency statement, I'm going to do the first one alphabetical, so ACD. I guess I'll do the bottom one, although I remember the order doesn't matter as long as it matches up correctly. So if I start with ACD, that should match up to triangle CAB. Well, one thing you may have noticed with this problem too is I could have added tick marks to that centerpiece. Remember, we called that the reflexive property. And so if I look now, well, I could also have used my other shortcut. Now I also have all three sides congruent, so I could also say the triangles are congruent by side, side, side. So I start to get multiple ways to prove triangles are congruent to each other. Either one of those would be fine. And for our last set of questions with side, angle, side, these are the questions that ask us for an additional piece of information. So we're not going to have enough information to prove the triangles are congruent, but that's the question. What else would we need to know? And specifically this time we want to use side, angle, side. So there are two sides I'll need to know, and I'll need to know the angle in between them. And so in my first set of triangles, I can see that I have the two sides already marked off. They're already congruent to each other. So in fact, if you want to think of like a checklist, you can check off side and side. They're already congruent to each other. So all that I need then is the angle right in between them. So there's any angle to pick from, but remember, I want the angle sandwiched in between those two sides. And so it's got to be that angle, and it's got to be that angle. Those are the two that are in between. And so the piece of information I would need is angle A, and I'm okay to use a single letter because there's only one angle there, is congruent to angle C. And I don't know that that's true. That's what I would need to know in order to use side, angle, side. Okay. In the second diagram, again, it looks like there's only one tick mark, but I disagree. I think there are actually two things we already know, because remember, we can add the tick mark for the reflexive property. So that piece is congruent to itself, and so once again, I have the two sides for side angle side. So all I need then is the angle right smack dab in between those two. And so if you see where those sides meet, it's going to be that angle up top and that angle over there. This time I can't just say angle A. There's too many angles there. That's not specific enough. So I'm going to need 3 letters to label that angle. So if I trace it out, I start at B, I go to A, and I finish at D. So angle BAD, A is going to be in the vertex, needs to be congruent to angle CAD. And again, I don't know that that's true, but that's what I would need to know is true in order to use side angle side.